Today's lesson is on transformations, and which includes translations, reflections, and rotations. A transformation is an operation that moves or changes a geometric figure to produce a new figure called an image. Now, one thing that's important about this is these images, they're going to stay congruent. So I'm not changing the size or the shape of the figure when I'm moving them. There are three main types of transformations. We have translation, reflection, and rotation, which we'll look at in today's lesson. Our first question asks us to name the type of transformation demonstrated in each picture. This gives us a good example to start with. In letter A, this is a reflection. We are reflecting the original image, called a pre-image, over an axis, so that's reflection. In example B, this piece right there tells us we're moving it, we're rotating, so this is a rotation. In our last example, letter C, we're just sliding it. That one's called a translation, and we also do just talk about that as being a slide. In our next example, we're looking at a translation. So we're given a quadrilateral ABCD. The vertices there are labeled, and to save some time, I've already plotted the points. I've also listed them in my pre-image. And now I need to do a translation of x plus 5 and y minus 2. So the coordinate notation, which is above, is x comma y, which is our first coordinate. That's our original. And then I'm going to go x plus 5. So that means I'm going to go 5 to the right. So in x, I'm going to go 5 to the right. And then my y minus 2 is telling me that I needed to go 2 down along the y-axis. So I'm going to take each point, I'm going to do that movement. So with A, I go 1, 2, 3, 4, 5, down 2. Here's my new point, and we call that A prime. Do the same thing with B. 1, 2, 3, 4, 5 to the right, 2 down, that's B prime. Do the same thing with C. 1, 2, 3, 4, 5, 2 down gives me C prime. And my last point is D. 1, 2, 3, 4, 5, 2 down gives me D prime. I'll connect all my points, make a new figure, and I'll label them. So now A prime is -1, 0. B prime is -1, 4. C prime is 1, 4. And D prime is 3, 0. Now to double check my work, I can go back and kind of look at my computation, looking at my x plus 5 and y minus 2, my movement. So if I take my x value, for instance in A, -6 plus 5, I should get -1. And I'll do the same thing with my y value. My original y coordinate for A is 2. I subtract 2, I get 0. So that looks good. I can check them all. B, I take -6 plus 5 gives me -1. 6 minus 2 is 4, so that looks good looking at my x and my y coordinate. I can do the same thing with my c value. I have -4 for x plus 5 gives me 1. And then for my y coordinate, I have 6 minus 2 gives me 4, so that one looks good. And my last coordinate, d, going to d prime, is going to be -2 plus 5 gives me 3. And 2 minus 2 for my 0 coordinate gives me 0, so that looks good. So it looks like that translation, I'm all set. We can also look at translations without using a graph. So for these questions, it says use the coordinate notation to describe the translation. Now remember, the translation is a slide. So my original coordinate notation is always xy, and I draw an arrow. Now if I'm going 4 units to the left, that's my x value. I'm going 4 units along my x-axis, so I get x minus 4. And if I go 3 units up, I'm going to go 3 units along my y-axis, so I'm going to go 3 units up, which is y plus 3. So my new coordinate notation is xy, and then I have x minus 4 and then y plus 3. And looking at number 2, I'm going to start the same way. My coordinate notation always starts with xy and then an arrow. 6 units to the right means I'm going to add 6 to my x value. And 7 units down means I'm going to subtract 7 units. So I end up with x plus 6 and y minus 7. Continuing with some different ways to look at translations, this next statement says if the coordinate 3, 4 translate to 6, -1, then 2, 0 translate to what? So again, I have to figure out what the movement is. So I started at 3, 4, and I went to 6, -1. So it might be helpful first to just write what the translation is. So what I did with x is I added 3, and then for y I went to 4, and then I went to -1. So that's actually subtracting 5. So now let's take my new coordinate point, 2, 0. If I add 3 to my x value, I get 5. And if I subtract 5 from my y value, I'm going to end up with -5. Looking at our next statement, it says if the coordinate -1, 2 translates to -3, 5, then what does the coordinate 2, 5 translate to? So again, let's come up with a coordinate notation statement. Let's figure out what the movement is. So my x-coordinate went from -1 to -3, so I subtracted 2. My y-coordinate went from 2 to 5, so I added 3. So there's my coordinate notation. So now I need to apply that to my new point 2, 5. So if I subtract 2 from 2, I get 0. And if I start with 5 and add 3, I end up with 8. So my new coordinate is going to be 0, 8. In our next transformation, we're going to look at reflections. This reflection is talking about going over the x-axis. So the x-axis is right there. So right now my pre-image, is in quadrant 3. When I reflect over my x-axis, I should end up in quadrant 2. So let's see what we have. I have my first point is E is -6, -3, and I'm along my -6, x equals -6, and I'm 3 down on my y-axis. So I'm going to go the same thing in the other direction. If I'm 3 below my x-axis, I'm going to go 3 above my x-axis, which is 1, 2, 3. And I'll label that E prime. I'll do the same thing with F. I'm 3 below. I'll go 3 above. That's F prime. Do the same thing with 6. My y coordinate there is -7, so I'm going to have to go +7. Up here is G prime, and then H prime is going to be right here. And then I will connect all my points. And now I'll list them in my chart down here. So E prime has the values of -6, 3. That's my coordinate. My coordinate for F prime is -4, +3. For G prime, I have -6, +7. And for H prime, I have -3, +7. Now when you're comparing the coordinates in my pre-image to my image, because I'm reflecting over my x-axis, you'll notice all my x values stayed the same, because I'm kind of in that vertical line. However, my y values have an opposite number. For instance, in E, I was at -3, and now I'm at +3. That's because I'm reflecting over the x-axis. Again, I'm going from quadrant 3 to quadrant 2. We're going to look at another reflection, but this time we're going to go over the y-axis. So right now, again, our figure started in quadrant 3, and we're going to end up in quadrant 4. So let's see what we have. So for I have -6, -3. So I'm going to work right along that horizontal line this time. And I'm going to end up over here is I prime. And that coordinate is going to be +6, still -3. My J, as I reflect over that y-axis, is going to be right here. That's J prime. And that coordinate is this time +4, -3. My K value, again, I'm 3 away from my y-axis. I'm going to go 3 on the other side, K prime. So that has a value of 3, -7. And L, again, same thing. I'll go kind of across that horizontal line at -7, and I'll end up right here at... There's my L prime. So that coordinate right there, I'll end up at 6, -7. So I'll connect all my dots there, and there's my new figure. That's my image. And again, similar to what we did last time, as we're comparing, this time because we were reflecting over the y, I'm still staying below the y-axis. So all my y values in this case are negative, and they're going to stay negative. But this time, my x values, again, are going to have the opposite effect. So they start as negative, and they all ended up as positive. The last form of transformations we're going to look at is rotation. Now, I think rotation is the trickiest of the three, and we have a couple different examples. So this one, we're asking to rotate the figure 90 degrees clockwise. So we need to make sure we pay attention to this rule. And remember, we're starting in quadrant 1. If I'm going 90 degrees clockwise, it means I'm going here. So I'm going to end up in quadrant 4. Now, if I rotate 90 degrees clockwise, that's the same thing if I were to say rotate 270 degrees counterclockwise, I would still end up in quadrant 4. So let's follow the rules. This time, instead of plotting the points right away, I'm going to complete the table and then I'm going to graph the points. So if I'm following the rule right here in M, so what it says is take my x value, my original x value from the pre-image, change that to be my y value, and negate it. So my original x is 0. I multiply that by -1. I still get 0. So that's going to be my new y value. My original y value is 2. That becomes my new x value. I'll do the same thing with n prime. So 0 times -1 is still going to give me 0. And then my 4 is going to be my x value. Now looking at my original o coordinate, again I'm going to take 2, which is my original x value, multiply by -1, which is -2. And that becomes my new y value. My original y value is 2. That becomes my new x value. Now let's plot these points. So I have 2, 0, that's m prime. 4, 0 is n prime. And then 2, -2 is o prime. So there is my new image. Again, my pre-image was in quadrant 1, and because I rotated 9 degrees, I ended up in quadrant 4. Looking at my next rotation, we're going to concentrate on rotating 180 degrees. So again, I'm starting in quadrant 1. This time I'm going to rotate, and it doesn't matter which way I go, but this rotation is going to go, if I go clockwise, I'm going to end up in quadrant 3. If I go counterclockwise, 180 degrees, I'm still going to end up in quadrant 3. So here's my rule. My rule states that my original coordinate xy is then going to become -x, -y. So I simply need to multiply each coordinate by -1. So let's look at p prime. That stays 0, -4. Q becomes -2 and -2 when I multiply -1 by both the x and the y. And my r prime is going to be 0, -2. So let's plot the points. So I have 0, -4 will be here. That's p prime. Q is going to be -2, -2. That's q prime. And then r prime is going to be 0, -2 here. And that will be my r prime. Now when I connect my points, there's my new image that has been rotated 180 degrees. In our last example of rotation, this time we're going to rotate 270 degrees clockwise. So again, I'm starting in quadrant 1. If I go 270 degrees clockwise, I'm going to end up in quadrant 2. And also note, it's the same thing as saying if I rotate 9 degrees counterclockwise, I'll still end up in quadrant 2. So similar to how I set up the previous examples, I have my coordinates all labeled and they're already graphed. I have to look at my new rule. So xy becomes -yx. So my original x value becomes my new y value, and my original y value becomes my new x value, but I need to multiply by -1. So let's look at s. So my original x value for s is 0, so that's going to become my new y value. My original y value is 4, which will become my new x value, but I need to multiply that by -1. We'll do the same thing for t prime. My 2 goes there, this becomes a -2. And my u prime, my 0 becomes my y value, and my 2, my original y value, becomes a -2 when I multiply that by -1. So let's plot my points. So I have -4, 0 is here. That becomes s prime. And then my t is -2, 2. And that becomes my t prime. And u is -2, 0. So I'm right there. And that's u prime. And again, I can connect it. And I've now just rotated that figure either 270 degrees clockwise or 90 degrees counterclockwise. They will end up in the same spot.